Okay, so next numerical we'll see where we are asked to draw the master and slave output waveforms for the following inputs. Okay, so this is JK flip-flop configured as T flip-flop. Okay, so again we are asked to assume output is 0 initially and ignore propagation delays. So we'll start drawing here as we had done. For this, first thing is you should remember what I told you is the function table. Okay, so this is the function table for T flip-flop, where we know that again if T is 0, my present output will be same as previous output, and if T is 1, my present output will be complement of previous output. However, for this to happen, my clock has to be 1. Okay, so we'll remember this and go to the diagram. Okay, so we need to draw here the output waveform. So first thing is we have to draw the output waveform for master, right, and slave. Okay, so for master and slave, we will draw the output waveforms. Just a minute. Master and slave. So we'll start analyzing. So up till here. Okay, so up till here what it is said initially, assume, in the question it is said initially you can assume the output is 0. So initially we'll assume the output is 0. So QM is 0 and QS is 0. Okay, now up till here. Sorry. Up till here, when my T is 0, clock is 1. Okay, T is 0. Okay, T is 0. It means if T is 0, my present output will follow the previous output. Okay, so QM is 0 and QS, it continues to be in the previous state till the falling edge of a clock. Okay, now again for the next part, see here again, see T has become 1. Okay, clock is also 1. So T is 1, clock is 1, means our output QM goes high. Okay, QM goes high. Now QM goes high, but what about QS? QS, okay, QM goes high, but see up till here we were drawing. Just a minute. See, please adjust. I'm not getting a straight line. Okay, QM is going high, but QS still retains its state because it has to change its state at the falling edge of a clock. Okay, so now up till where QM goes high up till here. Just a minute. Up till here. Okay, however QS is still low. Okay, now see, pay attention. See, this is the falling edge of a clock. It means at this edge my QS goes high. Okay, at this edge my QS goes high. Okay, now up till here we'll see. See here what happens, T continues to be 1, however clock goes to 0. Now if the clock goes 0, right, what is my output? My present output is same as my previous output. So QM is this and QS up till here is this. Okay, now Just a minute. I'll just take down the function table so that there's no interruption. Okay, right? So next state is this. See, up till here we'll analyze. Here what happens? C has become 0, right? And clock is also 0. C0, clock 0. Clock 0 means what? My output retains its previous state. So QM retains its previous state and QS again retains its previous state. Okay. Now next, up till here, see, my T is 0, clock is 1. Okay. T0, clock 1. Okay. T is 0, clock has become 1. It means what? My output QM T0, clock 1. It means my output QM will be complement of previous output. So previous output was what? 1. So now I get 0 up till here. Okay, I get 0 up till here, but however the slave continues its state till the falling edge of the clock comes. Okay, till the falling edge of the clock comes. Now next is up till here. Okay, up till here, up till the falling edge of the clock. Just a minute. Up till the falling edge of a clock we need to see here what happens. Clock is 1, T is 1 and clock is 1. T1, clock 1 means what? My output follows a previous state, complement of previous. T is 1. Okay, T is 1 means my output follows the previous state. Okay, so it is 0 here, and anyhow this state is not transferred to the slave till the falling edge of the clock. See, now the falling edge of the clock begins here. See, this is the falling edge of the clock. So here what happens? My slave goes to 0. Just a minute. My slave goes to 0 here. Okay, I hope up till here it was understood. Right? So you can analyze, I hope so. One more last I'll do. Okay, now here see, up till here T is 1, clock is 0. T is 1, clock is 0. It means my present output follows my previous output. So this stays to be 0 and this, sorry, yeah, this again goes to 0. Okay, so last one will do. Up till here, just a minute, up till here. Okay, see, up till here what happens? T is 1, clock is still 0. If T is 1, clock is 0, again I'll get same output up till here and this up till here, right? But see, here the clock is falling to 0 when T has become 0. Okay, here T has become 0. See, at this point T has become 0. So when T becomes 0 and clock also T becomes 0 and clock becomes 0, what happens? My output will follow previous state. So again this state continues here, right? If I see here, my this state will continue, this being 0 and this being 0. Okay, so this is the way how you need to analyze it, right? So for your convenience, I have given here the complete waveform. So please go through this and do step-by-step analysis. As I said, to do the analysis, you should be having the function table with you. Okay, that would make your work easier. Right? Thank you.